Hello everyone, this is Mohammed from Python Ninja YouTube channel, and by this tutorial we will finish the tutorials related to object-oriented programming, and starting from the next tutorial we will highlight data-oriented class, which is a branch of object-oriented programming. What we deliver so far is related to behavioral class, where the class is related to simulating the behaviors of the object. And in the next tutorial, we will highlight the data oriented class, where we can make an instance from the data itself. And in this tutorial, for the last tutorial in behavioral oriented programming, we will highlight duck typing, and by that we will close this tutorial. Duck typing is a concept in Python that focuses on the behavior of an object rather than its type. Meaning that if we have a class and we then make an instance from this class, then we will focus or give attention to the behavior of that instance, okay, that inherited from a class, rather than the type of the class itself. In Python, that means the type of the object is less important than the what the method and the attribute located in that class. Again, we give our attention to the behavior, okay, more than the type of the class itself. Okay, but the duck typing itself, this phrase comes from, okay, this sentence. If it's look like a duck, meaning that if like any object in the real world, okay, that looks like a duck and swims like a duck, and it also quacks like a duck, then it will probably be a duck, or it is a duck, okay? So we give similarity to the accumulated behavior. So for the duck, for example, if you have like any object that, or any animal, okay, that can be in the shape look like a duck, okay, and it's able to swim, it's able to quack, then it could be a duck, okay? And this phrase is a reference to the type of identification by behavior. So we identify object by behavior, okay, rather than its hierarchy, okay, and it's like actual type. Let's translate what I was describing in a view of coding. If I have a class, okay, and for example, I will have a class of Python developer, okay, and in this class I will only have an info, okay, method, and this info method will give me a print, okay, and we will say this object, okay, is able to write Python, okay, here. And at the same time, so this is a class of Python developer, okay, and we also have another class in the company. For example, it will be tech support, and for this tech support, if I have a method within the same method, okay, of the above Python developer, and I will also give a print here as a result when we call the method, and I will say this object, okay, provides technical, okay, support, okay. Now, if we want to like make the thing related to duck typing, I have two different classes, okay, and I want to call this method which hold the same name, okay, of the class, okay, and another method to get some information. For example, if I have a class information, and if I have inside this class information, I want to give a report, and I want also to insert the object, which is the instance that I will make later from the above classes, and I will extract from this instance, which now is the object, .info. Okay, so now .info looks like looks like a method that is located in both classes. Okay, and if anyone from the first glance can conclude that this could hold same content or the same result, but if you look here, if I call this method from this class, okay, then it will give me this result. But if I call this method, okay, which is info from the above the class, then I will have totally different result, meaning that I give the attention to the type, to the behavior, okay, of this function. So this function, when I call this, this method, when I call it, it gives me a result or behavior different than this method in another class within the same name, which is info here. So let us, okay, create here, for example, Python, okay, class. Okay, this is Python one, and this will take it from Python developer, and I will have nothing. I will also have from tick support, tick S, for example, and I will also take make an instance from the technical support. And finally, I will take information. This is information from information, and when I make this information, when I access the .inf from this instance, when I access the report, okay, and I say that, okay, give me the report of the Python one class. If I execute this, then this method, okay, will hold the instance here, and from the instance I will recall the .info method, and I recall this method, and it gives me this object is able to recall, which is this method. If I recall it again, okay, if I want, for example, to have a different report for a different instance, for a different object, then I will have, okay, different result, meaning that this class, which is information, focuses on the behavior of the instance rather than its type. However, both contains similar method, but each method behaves in its way. Okay, each method gives also different results. Okay, so let's make another example to make it also easy for you. If I have, for example, a class, and this class is called duck, okay, just to make it similar to duck typing, and this duck is able, for example, to quack, okay, and so when it's, for example, after swimming, so it looks like a quacking, okay, or when it's like walking, it quacks, okay. So I will print here, for example, a quack, okay. And if I have another example, so if I want to like project a quacking to a dog, so I will have the class dog here, okay, and I want to define the same quack, okay, a method here, but I want to also show different results here. I am a dog, okay, but I can also quack for some reason, okay, for some reason, okay. Now look at this. The duck typing in Python is the ability to recall, okay, or invoke a method that is located, okay, at many different classes with the same name, but it will give me different results, okay. So if I want, now I don't need to make class for information. I want to define a function which will make, for example, a quack, okay. And this function will take the object or the instance, and it will take the instance, okay, or object, okay, dot quack, okay. And now if I want to make an instance, for example, this is the from duck, okay, and no attribute for duck, and this is the from dog, and no attribute for dog, okay. And now if I want to recall the function make a quack, okay, so we make a quack from the object duck, okay, and from the instance duck, okay. Now I want to also make the same quack but for a different object, and now it's a dog, okay. So we have the same function, okay, from outside that will recall a quack, okay. And the quack is the same method that is located in both classes, and both classes are different. So the attention will be for the behavior or for the result of this class rather than the type of this object, okay. So we don't give too much about the type, if it's a dog or it's a duck. Now we give attention to the behavior, and the behavior can be drawn from the quack, okay, or who is fully quack, or who like fully quack for some reason, okay. So that can differentiate the behavior. And if we run the code, we can see make a quack when I pass the object, which is the instance duck, okay, give me quack. Oh, this behavior is totally different than the next behavior, which can quack for some reason, okay. And this is like the exact example of the duck typing in Python. And remember that in duck typing in Python, in a simplest way, when we have like more than one class that hold the same function or the same method, okay, when we call the method, don't expect that you will have the similar result, because you don't give attention to the type of that class rather than the behavior, okay, that is embedded in that class. Let us close this by another example also to make it more and more clear. So suppose you are in a factory, okay, that like fabricate toys, and if you have, for example, if you have a rubber duck, okay, this is a toy for kids, and suppose you want to simulate the packaging line, okay. So you have, for example, package, okay, and in this you want to return, for example, packaging a rubber duck, okay, in a plastic, okay, bag. Okay, suppose you have also another type of these toys. For example, I have for example toy car, okay, and I also within the same packaging line in the factory, okay, I have the same package function here, but it will give me a different behavior, sorry, return a different behavior. It will say packaging, okay, toy car, okay, and like in a different plastic bag, toy car, because it could be broken. I want to use cardboard, okay. I want to cardboard use because I want to use cardboard box here. Suppose I have also what are kind of toys. For example, if I have a stuffed animal, okay, and for this stuffed animal, and I want to have cardboard, and for this stuffed animal, I want to have also packaging. Package or method, so these should be the same, okay. So sorry for the typo, that's outside of my hand, and I want to return now, okay, a string that say that I want to wrap, okay, the stuffed animal, okay, and let us to say tissue paper, okay, like this. Suppose it is. Now if I have a class that will check, okay, the behavior okay, and the packaging line based on the type of the toy. For example, like let us to say that we have a back toy, for example, packaging like this, and I will have now a function, and this function will say package, okay, package toy. Okay, and I want to submit now the object with, or I want to submit the toy now. Okay, it is the same. If you want to submit whatever you want to submit in the argument of the function, then you will have no problem. If I want to, for example, print the toy dot package. Okay, so this is the logic. I have a packaging line. I have different classes. I have the rubber, duck, toy car, and stuffed animal. We have the same function in the line, which is packaging, but it should behave, okay, in the different way for each toy. So, however, the pass to the same production line for packaging, but it will behave, okay, in a different way. Okay, so by this way we focus or give attention to the behavior of the object, not the type. So okay, and now I designed another class that I will pass through it the instance, and from this instance I want to recall this packaging. Now I want to make a rubber duck, which come from the rubber duck. I want to make car, which come from toy car. I want to make also, let us to say we have the beer, and this will come from a stuffed, sorry, which will come from stuffed animal. And I want to make another instance from this just to give me the result. So I want to have, for example, a factory will be our production line, or whatever you want will be toy packaging here. And if I want to say the factory dot package toy, and I want to submit the duck, okay, I want to copy and paste this, okay, and I want to submit here the car. Here at the beginning to the duck, here we have the car, we have here, okay, there, okay, and when I run this, I want to see the result. Okay, so I call the same function, okay, among the three different objects, okay, irrespective that we have the same function that is located among these classes or the same method, but the method behave in a different way. The method behave on the class that is located in, okay, so we now recall or invoke the package toy, and we can see here different results come, okay, or show to me based on the behavior, okay, that can be drawn, okay. And that's the duck typing. Remember that in principle, the duck typing is a concept in Python. In general, if you have 2 or 3 or whatever number of class you have, if you have the same function or the same method in that classes, then each methods, okay, inside that each class, okay, that hold the same name will behave in a different way, okay, than the others, okay. And yeah, thank you for watching this tutorial, and please don't forget to subscribe and share this tutorial. See you in this tutorial where we want to introduce data oriented class.